Alright, so if we're going to be working with two variable equations like this, it would make sense that we are going to be comparing these two variables. So we're going to talk about a way to compare the variables, and it's called a ratio. Here are two ways that we write ratios. This way is read x to y. The colon stands for the word 2. And you can also write a ratio as a fraction. Fractions are in fact ratios. Okay, a ratio can pretty simply be defined as a comparison of two measurements or quantities. Suppose, for example, we want to compare the perimeters of these two triangles. The blue triangle is clearly smaller than the green triangle, but a ratio allows us to describe how much smaller. And I don't mean how much smaller in terms of, well, look, the blue triangle has a perimeter of 8 centimeters and the green triangle has a perimeter of 12 centimeters. When I say how much smaller, I don't mean 4 centimeters smaller. I'm talking about a ratio. It's really more like how many times smaller, if you will, or really how many times bigger is the green guy than the blue guy. So if we have the question, what is the ratio of the perimeters of the blue triangle to the green triangle? We would simply write that as blue triangle is 8 centimeters to 12 centimeters. Now, the centimeters are the same units, so really we can just write this as 8 to 12, which naturally could be more simply written as 2 to 3. 2 to 3. There's the ratio. That doesn't look very much like a colon. It looks more like an exclamation point, but that's a colon. 2 to 3. Now, we could also write the ratio this way. 2/3. So we could write it as 2 to 3 or as 2/3. And the significance of the 2/3 is, well, we could say that the blue triangle is 2/3 as big as the green triangle. The blue triangle is 2/3 as big as the green triangle. Now, what if the question were, what is the ratio of the perimeters green to blue? Well, naturally, I hope that would just be the other way around, 3 to 2. Or we could write as 3/2. 3/2. The blue triangle is 3/2 as big as the green triangle, 1.5 times bigger. Now, there's some familiar ratios that you've seen probably. One example is aspect ratio of a TV screen or a computer monitor. Full screen aspect ratio is a 4 to 3 ratio, where the length of the screen is 4/3 times as long as the height of the screen. Widescreen TVs, widescreen computer monitors, usually the aspect ratio is 16 to 9. The length is almost twice as long as the height on a widescreen television set, and that's referred to as aspect ratio. That's the technical term. You might see that on your TV remote. Another, not familiar, but I know you've seen this, I'm sure you've seen this famous painting by Leonardo da Vinci, the Mona Lisa. And this is another drawing of Leonardo's called Vitruvian Man. Well, Leonardo, supposedly, there's debate as to whether he really was intentionally doing it, but supposedly he implemented the golden ratio, which is supposed to be aesthetically pleasing to the eye, the rectangular ratio. Um, and supposedly he used it in his art. The ratio of the height of um, Mona's face, of Lisa's face, not Mona. Mona means my. Of Lisa's face to the width of her face is with the ratio of the belly button to the belly button, the top of the head length in Vitruvian Man, and supposedly it's pretty close to that for most human beings. So that's the golden ratio, and the golden ratio is really, it doesn't look like that big of a deal. It looks kind of complicated, but it's really pretty cool. It comes up in nature quite a bit, but I obviously don't have time, nor is this the appropriate place to talk about that. Another place that you've seen a ratio is when you see, oh, come on now. Why won't that thing go away? There we go. I don't want to mark there. Okay. When you see the odds of winning a jackpot or winning a lottery, those odds are expressed as a ratio. Technically, usually they're expressed as odds of losing because you have 175,711,535 ways to lose and only one way to win. So that's the odds. I looked that up on the internet actually. I obviously don't know that. I don't gamble. That's why it's silly to gamble. The odds of you have one way to win and over 175 million ways to lose the Mega Millions grand prize, or not to win. So those are three examples of where you've seen ratios, or you weren't thinking about a ratio, I'm sure, when you looked at the Mona Lisa. But anyway, so how about a problem involving ratios? Pretty simple. The Chicago Bulls 1995-96 season, they won more games than any other team in NBA history in that single season. They won 72 out of 82 of their games. Back in the days of Michael Jordan and company. I think this was his first year back from retirement. I don't really follow NBA. I used to a little bit, but not anymore. Anyway, no other team has even won 70 games in a season. So, what was the ratio of their losses to their total games played? Well, if they won 72 games, since there are no ties in the NBA, that means they lost 10 games. So their ratio of losses to total games was 10 to 82, which we could simplify as 5 to 41. 5 to 41. Now, does that mean we could also express that as a fraction? 5/41. Now, in this case, it kind of is not the best to express it as a fraction because it makes you think 5/41. They lost 5/41 of their games. No, the numerator is how many they lost, and the denominator is, oh wait, I take that back. This is correct. They lost 5/41 of their games because 82 is the total number of games. Alright, so how about the ratio of their wins to losses? Well, they won 72 and they lost 10. They had a 72-10 record. So you could actually reduce that to, let's see, that would be 38. 38 to 5, if we wanted to reduce that ratio. 38 to 5. Now, they had a 72-10 record. That's how they express. So they express their record kind of as a ratio, but the form requires a colon. 38 to 5 ratio of wins to losses, and that's just a simple example of ratio. And that's all I have for this video.